Hello, my name is Tangi Beverly. I'm going to be talking about ancient Egyptian mathematics for my History of Mathematics class, spring 2017. So a little background information about Egypt. Egypt is a country in North Africa located on the Mediterranean Sea. To the Egyptians, their land was known as Kemet, which means black land, for the rich, dark soil along the Nile River. They were known for great pyramids of the Old Kingdom through the military conquests of the New Kingdom. Monuments, objects, and artifacts told the history. The monuments which Egypt worshipped to reflect the Egyptian culture, which influenced so many civilizations such as Greece and Rome. Egypt thrived for thousands of years as an independent nation whose culture was famous for advances in human knowledge, art, mathematics, science, technology, and religion. Origins of mathematics. Egyptians are largely responsible for the foundation of mathematics with the knowledge and techniques passed on to the Greeks, helping the Hellenists to develop their mass of mathematical knowledge. Numerals. It was two number systems were used in ancient Egypt. One of them, written in hieroglyphs, was a decimal-based tally system with separate symbols. The other one were written in a new cipher, one number to one symbol system, was a digital system that was not similar to the hieroglyphic system. Counting with hieroglyphs. These are the basic glyphs used in Egypt for counting, and glyph stands for symbols. Hieroglyphic number system exists from at least the early dynastic period. The hieroglyphic system differed from the hieroglyphic system beyond a use of simplifying for a rapid writing and began around 2150 BC. The hieroglyphic numeral used one symbol for each number, replacing the tallies that had been used to denote the multiples of an unit. The written mathematical papyrus was written in hieroglyphic. It contains examples of how the Egyptians did their mathematical calculations. Addition and subtraction. Addition and subtraction were processed using the counting glyphs, which mean symbols. Add two numbers, collect all the symbols of similar type, and replace a 10 of one type by one of the next higher order. Subtraction is just a reverse process of addition. To the top are the symbols for addition, and to the bottom are the symbols for subtraction. Multiplication and division. Their multiplication was done by doubling of the number to be multiplied and deciding which of the doublings to add together. To be able to multiply two numbers, all you would need to understand was the double or the half of an integer. Division is just a reversal of a multiplication process. And to the top is how we will multiply numbers, and to the bottom is how ancient Egyptians multiply numbers with the symbols. Fraction barely exists for the European civilization until the 17th century and even in the 19th century. A method called Russian passive fractions was the same used by the Europeans since they met the African and Egyptians, at least since 4000 BC in Egypt. As the method was found on several papyrus, we now call this technique Egyptian fraction. Rational numbers could also be expressed but only as sums of unit fractions. Sums are the reciprocals of positive integers 2/3 and 3/4. The hieroglyphs indicate a fraction look like amount, which means part. And the fraction was written with this fractional solidus, the numerator 1 and the positive denominator below. Special symbols were used for 1/2 and for two non-unit fractions. 2/3 were used often and 3/4 was used less often. A unit fraction form is 1 over n, where n is a positive integer, and the Egyptian fraction is an expression of the sum of unit fractions, 1 over a plus 1 over b plus 1 over c, such and such. The denominators a, b, c are increasing. An Egyptian number is any number equal which can be expressed as the sum of an integer plus the sum of an Egyptian fraction. 1/2 plus 1/3 equals 5/6 is an Egyptian number. 1/3 plus 1 over 11 plus 1 over 231 equals 3/7 is an Egyptian number. They made note about the fraction 2/3. 1/5 plus 1 over 337 plus 1 over 4070 and 1/6 plus 122 plus 166 are different Egyptian fractions despite the sum is 5 over 22. 3,900 years ago was dated as the earliest records of Egyptian fraction in the papyrus copied by Ahumes. The rule of Egyptian fractions required us to write only unit fractions, integers, and their sums. The theorem, every rational number is an Egyptian number. The modern proof of the theorem was discovered in 1880, but Europeans have known how to compute Egyptian numbers since the Fibonacci in the 12th century. Suppose P over Q less than 1 is written in the lowest term, then there is an Egyptian fraction which at the most P terms, and whose number is P over Q. Let R over S equals P over Q minus 1 over Q over P. So P over Q equals 1 over Q over P plus RS if R equals 1. And here are a couple examples for the proof. So I've been gathering my information from the website Mathematician of the African Diaspora, and their website is about that I have heard people saying the Negro is incapable of succeeding. So the main purpose is to show the many accomplishments of people from Africa and the African diaspora within the mathematical sciences. So the Egyptian zero, the symbol for the Egyptian zero was the same as the hieroglyph for beauty complete and a abstraction of the Egyptian of a human windpipe, heart, and lungs. The consonant sounds were NFR, but the vowel sounds are unknown. The same NFR symbol was also used to express the zero remainders in the monthly account sheet from the Middle Kingdom Dynasty 13, dated back 17,070 BCE. The bookkeeping records looks like a double entry account sheet with a separate columns for each type of goods. At the end of the month, the account was balanced. For each item of income was added, then the disbursement were totaled. Finally, the disbursement total for each column was subtracted from total income from the column. Several columns has zero remaining, shown by the NFR symbol. Egyptian mathematics papyri. There are two main sources on Egyptian mathematics. The Rendon papyrus and Moscow papyrus. Between both of them contain 112 problems with solutions. The secondary sources are three papyri from 1800 BC. Egyptian mathematical love, which is a table of 26 decompositions on unit fractions. The Berlin papyrus is two problems of simultaneous equation, one in the second degree. The Ryzen papyrus are a volume of calculation, and the Egyptian mace head contains a record for winners of the war of the pharaoh Namar. It uses a number system allowing counting to continue by inducing a new symbol. Moscow papyrus. It was copied by an unknown script. It was brought to Russia during the middle of the 19th century and is located in the Museum of Fine Arts in Moscow, containing mathematical problems and solutions. And here is problem 14. The Egyptian mathematical railroad is a table containing 26 decomposition into unit fractions. The Breton papyrus are two problems in a simultaneous equation, one of which is the second degree, and they are translated. Here's the problem 1 and the solution. The Qom papyri is a 6 mathematical fragments. It is not translated. The Rhind papyrus, named after the British collector Rhind, which acquired it in 1858. It was copied by the scribe Ahims from another document written in 2000 BC, which will most likely come from another document from 1500 BC. The Rhind papyrus is located in the British Museum and contains mathematical problems in solution. And here's problem 24 and the solution. Some information about Ahims. He was an ancient Egyptian scribe who lived during the Second Intermediate Period in the beginning of the 18th dynasty. He was a mathematician, and some of his work is part of the Rhind mathematical papyrus, and his work is entitled Directions of Knowing All Dark Things, and is a collection of problems in arithmetic, algebra, geometry, weights, and measures. The 51 member of the 2 over n table and the following 87 problems were presented with red auxiliary numbers. Ahims offer brief notes for hard-to-read auxiliary number steps for the 20th century scholars. After carefully reviewing the documents like the King Wooden Table, Egyptian mathematical leather roll, Reisner Papyrus, and the Moscow Mathematical Papyrus, and the theoretical review of Ahims' arithmetic was found after 2002 and published in 2006. The Egyptian fraction notation replaced the Old Kingdom binary fraction, the Horus-I notation, a strange round-off system and Old Kingdom form of the multiplication used by Ahims as a proof method. His method was taught to him and later passed down to scribes, wrote fractions in exact ways, never round off when the rational numbers were involved. Egyptian fractions are scripted away easy to read rational number arithmetic is disposed revealing modern looking arithmetic operations. Algebra. Appearing in both the Rhind Mathematical Papyrus and the Moscow Mathematical Papyrus, as well as several other sources. AHA problems involve finding unknown quantities, sum of the quantity and parts are given. To solve these AHA problems involves a technique called the method of false position. It is also called the method of false assumption. A scribe who will substitute an initial guess of the answer into the problem. The solution using a false assumption will be proportional to the actual answer, and the scribe will find the answer by using this ratio. The mathematical writing showed that the scribes used least common multiples to turn the problems with fraction into problems using integers. And the red auxiliary numbers are the multiples factors were often recorded in red ink. And the use of the Horus-I fraction shows some knowledge of geometrical progression. Mathematical sources evident of the knowledge of the arithmetic progressions. Quadratic equations. Ancient Egyptians were the first civilization to develop and solve the second degree equations. This information is found in the Berlin Papyrus fragment. Egyptians solved the first degree algebraic equation found in the Rhind mathematical papyrus. Geometry. There are a limited number of problems from the ancient Egypt that contribute to geometry. Geometric problems appear in the Moscow and the Rhind papyrus. The examples that were provided demonstrate that ancient Egypt knew how to compute areas of several geometric shapes in the volumes of the cylinders and pyramids. And they found areas of triangles, rectangles, circles, and a hemisphere. Volumes of the cylinder, rectangular, and truncated in the pyramid. Thank you for taking time out your day for watching my video about Egyptian mathematics. I feel inspired that I learned about mathematician and African Diaspora to help relay a message that other people from races that have contributed to mathematics. Thank you.